Hi there, and welcome back to another video. So in this video, I'm going to be showing you how to plot using PowerShell, and I'm going to be showing you how to do some parallel plotting along with staggering those parallel plots and keeping them going. But we are going to start off basic, so if you never even opened PowerShell before, you should be able to follow along. Now, before we get started, you might want to ask yourself, why are we plotting in PowerShell to begin with? Because as the GUI currently stands, it has almost all the features in it, and so I think that the GUI is actually pretty good, and I did most of my plotting in the GUI. But there is one big drawback, and that is that it's connected to your farm and your wallet. So if your farm is having issues or your wallet is becoming out of sync, then you might have to close the GUI, and when you try to close the GUI, well, it will end all plotting processes. Now, plotting takes a long time per plot file, so this is a bit inconvenient. Another advantage of plotting in the PowerShell or command line is you can run it on harvesters that don't run full nodes or don't run the GUI. Now, those are the two big advantages. With that being said, if you're having a lot of success plotting the GUI and you're not running into a lot of issues with your farm or your wallet or anything like that, then I do suggest sticking with the GUI if you have a consistent process going, because consistent results is more important than anything. And the command line is not inherently faster at plotting than the GUI. The only advantage is you can customize it a little bit more and tweak it a little bit more to get a little bit more out of it. Now, with that being said, let's go ahead and just jump right into it. Now, like in all my videos, I highly recommend checking out the wiki for the subject that we're talking about. In this case, it's the command line reference page. And here it'll tell you that you need to go to the folder that the Chia executable lives in order to use it, and it gives us the Windows path right here. However, this path has a little bit of a problem with it in the fact that it changes every time you update Chia, and it changes right here with the version number. So if I just try to copy this, leaving off the chia.exe part into PowerShell, let me maximize this, and I do cd for change directory, and I try to go to that location, well, it will fail because I'm not on that version. Now, if I try to run it again and change it to the version that I'm on, you can see that it works. Now, this is fine and good, but this can be kind of annoying to have to do every time you open up PowerShell and you want to use a Chia executable. And we don't even need to really be in the directory to use it. We can actually add it to a path that PowerShell already looks, and we can add it to this variable right here. So PowerShell will actually look in all these folders for executables to run. So if we add it to this, well, it will find it, so we can be in any directory that we want to be in. Now, I'm just going to give you a quick commands to run so that you can just run this once and you can just forget about it forever. So I'm going to open up this, and then I'm going to have this at my GitHub, and I'll have a link to that in the description below. And if you just copy this into PowerShell and you run it, so if I just run it right here, nothing will be outputted, but if I close PowerShell and then I reopen it and I type out Chia, well, you can see that I actually found the Chia executable that we want, and I can do -help, and here we can see that the Chia executable is working. So this is a very quick shortcut, and this will work for all versions of Chia. So if the version updates, well, this will work even after the update. So I recommend doing that little quality of life improvement before you even get started. Now, essentially what we're doing here is just adding two commands to our profile script, and our profile script runs every time that we open up PowerShell, which is why we had to close PowerShell and reopen it for it to take effect. Now, the first command that we're adding is just grabbing the path of Chia, and we have this asterisk here to grab any version of Chia that you are on. And then we add this path to the environmental variable that we saw earlier, and just add these two commands to our profile script right here. Now, the second quality of life improvement you want to do is open up PowerShell ISE so that we can write script files. And you can actually get to the PowerShell ISE directly from PowerShell by typing out ISE and hitting enter, or just going through Windows and searching it that way. Now, why do we want to use PowerShell ISE? Well, it's a scripting engine, so it allows you to create script files that you can then reuse in the future And then also these script files serve as like documentation. So if you forget how to do something, well, you can kind of go back to where you've done it before and look how to do it. Now there's just really one thing that you need to know in order to use the ISE, and that is that the top part is where you write your scripts, and the bottom part is just a built-in PowerShell window, just like this one, but built into the ISE. Now you can write your scripts like get location, and it has some IntelliSense built right into it, and if you hit enter, you can see that it doesn't run the command because you're writing a script. And then you can save that script by doing File, Save As, and save this in a script file or a PS1 file. Now if you do want to run one command on one line, you can just hit F8 when your cursor's on that line, and it will run that command. So with all that out of the way, let's go ahead and write our first Chia plotting script. Now let me go ahead and maximize this and make it a little bit bigger. And we're actually going to do it side by side to the GUI so that you can really get a clear understanding of what each part is. Now in order to know how to plot Chia using the command line tool, you're going to have to reference the help quite a bit. And you can go to the command line reference page, and I do recommend at least reading through this once because it has additional information here, but you can also access most of this information directly in PowerShell. So let's go ahead and clear that out and type out chia.exe, and then you create plots by running the command plots, create, and then you can get the help and the parameters to use by typing out -h after that. Now hit F8 and it will run the command below, and then here you can see that it gives us similar help information directly in PowerShell. Now a little trick is that you can make this its own little window in case you want to keep referencing it by doing out, or doing the little pike or vertical bar, and then typing out out grid view. Now let's hit F8 again, and here you can see that it opens up another little window that we can have at our disposal. Now it's a little bit formatted weird, but it gets the job done. So let's go ahead and do a comparison one by one with the GUI and the parameters in the command line. So the case size is actually listed in order. So here, the default is K32, and here it says default is K32. So if you're doing 32, you actually don't even need to use this parameter. The -n is the number of plots, and here we can see that this is also the number of plots right here. So the default is also 1. So if you're doing 1, you don't need to change this. If you are, well, then you do need to change it. So let's go ahead and start writing our command right now. So let's do -n, and let's create 2 plots for this example. Alright, so let's go down, and then here we can see the buffer, so it's -b. So if we click choose advanced option, so this is the value that we're changing here. Now the default is going to be the same as the one in the GUI, so that's why I think that the one here is a little bit outdated, because it says the default is this amount when really it's a lower amount. Now if you're just going to use the default, you don't even have to specify this parameter either, but for the sake of example, I'm going to allocate a little bit more. So I'm going to do -b and allocate 4,000. So if you change this to 4,000 in the GUI, well, you would put 4,000 right here. Now the next thing will be threads, and that's indicated with the parameter -r, and the default in this case is 2, as it is in the GUI. So if you're doing 2 threads, well, again, you don't need to change this. However, for this example, I want to do 4 threads. Now the next 4 parameters I think you can just actually ignore. So the buckets you really don't want to mess with unless you know what you're doing. And then these 3 parameters are for if you're running this command on a machine that doesn't have your private keys. For instance, like a harvester that you didn't import the private keys into. Now I did go over that in a different video, so I won't go into that now. So let's go ahead and move on to the next one. So the next one is -t. So this is going to be your temporary directory, most likely your SSD. And this can be found here in the GUI. So this is what you're changing right here. So this is going to be a path to that directory. So let's go ahead and indicate it with -t and just start typing this out. So mine's in my P drive and then in my plot folder. Now of course you can go to File Explorer and then just copy the path if you want to do it that way. So let's go back to the parameters. And the next parameter is -2. So this is going to be the second temporary directory. So if you do show advanced options, this is what you would be changing with that parameter. In my case, I'm not using it, and if you haven't used it in the GUI, then you probably won't use it in the command line as well. So we can skip that one. Now the next one after that is going to be -d, which is going to be the final directory. So if we do -d, we can list out where we want the plot to be placed once it's done being created. So mine's in my H drive, and then Mr. Pig, and then farm. And you can hit tab to complete the autocomplete that's giving, the suggestion it's giving down below. Alright, so we have a couple more parameters that we can go over. We're going to want to skip this parameter because for debugging purposes, again with the memo parameter, you won't be using that one. Now the -E will disable bit field. Now you want to use bit field most likely, so unless you specifically know that you need to disable it, just don't use this parameter. And then the one after that is going to be the -X. So basically this will, if you check this box in the GUI, then you would just type out -X in order to exclude this path right here from your farming. Now, more than likely you don't want to be doing that, so we're going to leave that parameter off. Okay, so now that we've finished writing our first Chia plotting script, let's go ahead and save it into a PS1 file so that we can run it in the future or make changes to it as we need. So I'm going to save it as Chia basic plot and just click save. And then now I'm just going to run it by hitting F8. Now you'll notice that it actually looks like it outputs an error whenever it runs. However, this is not the case. This just goes to the error stream, this little header part right here for some reason. But I noticed that in my testing, and this is perfectly normal. Now here it gives you information just like the logs in the GUI. So it says, plot size 32. You can see that our change to the buffer got changed right here. So it's 4,000 MIBs, and then 4 threads are being used. Now, the one disadvantage of using PowerShell is by default it doesn't create log files. Now when you use the GUI, it actually has the advantage of automatically creating log files. Now you can get to these by going to the C drive and then clicking on users, your username, and then .chia, mainnet, and then plotter. And here you can see all the log files that I got whenever plotting in the GUI. And then you can use these to give you information about the plotting process and better optimize your plotting. Now you can see that we just started a plot right here. However, a new plot log file was not generated. Now this is pretty easy to set up in PowerShell, and I'll go ahead and show you how to do that. So I'm going to go ahead and cancel this by hitting Control-C. Now if that doesn't work, you can always just close the PowerShell window to end the process. And then I'm going to go delete the temporary files real quick. Okay, so I finished deleting the temporary files. Let me go ahead and minimize that and expand this. So in order to generate log files in PowerShell, you're going to actually want to pipe or take the output of this and throw it into the command called tObject. Now what tObject does is it redirects the flow of the information that you're giving it into a file. So then we can do file path, and this is going to be the file path where you want your logs to be generated. So I'm going to generate mine in my h-Mr. Pig-Chia logs, and I'm just going to call this log something simple like plot1.log. And now if we hit F8, we'll see that we get the same output as before, but let's go ahead and go to this location here. So if we go to File Explorer and we go to my H drive, to Mr. Pig, and to Chia logs, we can see that there is a log file called plot1. So now if I open this up, we can see that everything that was put into the PowerShell window is also being generated here. However, you can see that this part right here is not being thrown into the log file, since that is actually an error stream. Okay, so now that we've learned how to log our PowerShell plotting, let's go ahead and look at how we can do some parallel plotting in PowerShell as well. So I'm going to close out of this, and I'm going to cancel this plot right here and go delete the temporary files. Okay, so let me clear out the screen right here, and then if we go to Windows Tips and Tricks, they actually give you some guidance on how to do some parallel plotting in PowerShell. However, they do have a mistake right here. Now they do tell you correctly to get to the directory where the Chia executable will live, but they give you the wrong command to run in PowerShell, because this command only works in the command prompt. So if we copy that command and we run it in PowerShell, we can see that it fails, because these two things right here, system drive and home path, are environmental variables meant for the command prompt. So if we run this and the command prompt, you can see that it works correctly. Now, I do hope that they fix this in the future, because this does look like it's supposed to be ran together, since start process is a PowerShell command. So we're going to be using the stop process command to help us create parallel plots. So let's go ahead and go back to our PowerShell ISE, and let's type out start process. Now, what does start process do? Well, it simply starts a process that you give it with a file path. So if we gave it the file path notepad.exe and we run that, well, you can see that it starts a notepad process. However, we want to start a Chia plotting process. So let's go ahead and convert this up here into a start process command. So we can copy the chia.exe file path right here, and then the next argument, or the next parameter that you want to use, is the argument list. And the arguments are everything that you wrote after the chia.exe. So we can copy all of this, and we'll leave out the logging part of it for right now. And then we want to enclose these in double quotes. So I'm going to paste this into double quotes. So now if we run F8, we can see that this command runs down here. It frees up the command prompt in this PowerShell Windows, a new command prompt with the Chia plotting process starting. Now, why is having this plotting process in a separate window so useful? Well, it frees up the command prompt that we started the process from, so now we can run the same command again and create another queued plotting process, effectively creating parallel plotting in PowerShell. So if we run this command again, it will open up another PowerShell window starting another queue of plots to be created. So we effectively have two parallel plots going, just like we would if we ran plots in parallel here and then ran two right here. And since we didn't really have a delay between these two, that would be effectively a zero delay, like it would be in the GUI. So how do we add a delay in PowerShell like we do in the GUI? Well, let me go ahead and close out of these plotting processes and then delete the temp files. Okay, so let's go ahead and go back to the PowerShell ISE. And since we're not using this command anymore, we can go ahead and comment that out by using the hashtag, and it will ignore this line right here if we run this file. So how do we delay our parallel plots in PowerShell? Well, if we go down here and we add a command called start sleep and then do the parameter seconds, well, this will basically halt the shell for however many seconds that you give it. So if you give it 60 seconds and we run this, well, it will pause the PowerShell shell for 60 seconds until it runs before it runs another command. So I'm going to cancel that right here. So this would be effectively adding a delay like we do in the GUI, except instead of minutes, we're using seconds. So let me go ahead and just change this to, let's say, 15 seconds for an example, but you might want to change this to about an hour or 3,600 seconds. And then we're going to want to copy this same command up here and do it right below here. So we're going to be creating two queued parallel plots that will create two plots each. So if we run all three of these lines, PowerShell will run the first line first and then create a plotting process, and then it'll run this line right here and wait for 15 seconds before running the line after that and create another parallel plot or another queue of plots for two. Now, you could just keep on adding lines like this. You could add another sleep command right there and then add another queue of plots to run after that. So then you'll have three parallel plots all staggered by 15 seconds. You definitely want to do a longer duration than this. This is just for example. But there is a more effective way to do this, especially if you're going to be running, let's say, 7 parallel plots. And we can do this by using a for loop. Okay, so in order to make this simpler, we're going to put this in a for loop rather than just copy and pasting these commands over again. So we have a for loop right here just for demonstration purposes. So the first thing that we do is set a variable called I to 1. And then we say if this variable is less than or equal to 3, we'll then run everything in this script block. So run this right here and then run the sleep command. And then we say after the script block has been ran, increase the number in I by 1 value. So if we run all this right here, we'll see that outputs 1, because that's what's stored in I. It sleeps for 2 seconds, and then outputs 2, and then 3, and then the for loop is done. So now if we replace the I with the start process command by starting a queued plotting of Chia, well, we can see that it opens up a Chia plotting window. It waits for 15 seconds, and then it will open up another one, creating 2 parallel plots, waits another 15 seconds, and then opens up another one. So this really helps you consolidate your code and makes it kind of easier to control it. So if you wanted to do 4 parallel plots, well, you can change this to 4 or 5 or however many plots you want to do in parallel. And it also allows you to quickly change, the delay that you want to add. So if you want to just do a, let's say 3,600 seconds, well, you can quickly change that in 1 spot instead of having to change it in 7 spots if you just copy these commands over and over again. So now you have your first Chia plotting script file. So let's go ahead and clean it up by deleting this, and then let's save it. So now if we open up PowerShell in a new window, we can run this script file, and it will do everything in here that are outside the comments. So if we minimize this, we can actually run the script from this other PowerShell window. So my script is located in the Z drive, YouTube, PS scripts, and then it's called Chia basic plot. And here we can see that it runs the command in that script file. So it started the process. Now it's going to wait 1 hour, and then it's going to go through the loop again and start another process. So now we have 3 parallel plots that will be staggered by 1 hour, each creating 2 plots, or 6 plots in total. Now, log files are very helpful whenever creating optimized plotting. So let's see how we can integrate logging into this, what we have working here. Now, unfortunately, we can't just copy this like we did above into here, because this only accepts the arguments that go along with this executable. So if we run this, this will fail. So we're left with 2 options. We do have an option with the start process by using the redirect standard output stream. So this will redirect the stream not going into the PowerShell window, but going into a log file, and we basically would do the same value that we did for the file path for tObject right here. Now the downside of this, let me go ahead and cancel this right here. Now the downside if we run this right here is that it doesn't output anything in this. So you don't have a nice stream of where your plot is at, but it does create that log file like it did before. So here we can see that it created this file right here. So what is our other option? Well, our other option is, instead of starting a Chia process, we can start a PowerShell process. So let's do PowerShell.exe, and then let's just add the Chia right here, .exe, add the space, and now we can add this pipe like we did before. And then let's get rid of this parameter right here. And now let's run this using a PowerShell process instead of the Chia process. So now if we run this, we can see that another PowerShell window got generated just as it did with Chia. And we're seeing that it gets outputted to the PowerShell window. And if we go back to where the log file is, we can see that it generated a new one, 1103, it's 1103, so we have one generated. However, this will be overwritten whenever we start the next parallel plot in 1 hour. So we kind of want to make these unique. So how do we do that? Well, let's do it by adding a timestamp to the beginning of them and making the number right here the number in which we started this parallel plot. So in order to get the time, we can use the getDate command, and then we can format this in the format that we want. So we can do year, year with a dash, and then do month, month, day, day, and then we can do hour, hour, minute, minute, and then second, seconds. So let's go ahead and store this into a variable called date, and then if we run this, or let me go ahead and cancel that. So if we run this right here, we can see that it created a string with the date and the format that we gave it. So it's year, month, day, and then the hour, minute, and seconds. So now let's go ahead and add this variable right here. So date, and then let's change this variable to I. Now we will have to enclose these in parentheses with a $sign in front of them. And then now let's go ahead and run this one more time. So if we hit F8, it creates the new window as before, except this time it created a log file with the timestamp right here in front. Now I did forget to do maybe a little dash right here for this number, but you get the idea. So let me go ahead and fix that real fast. So I would just need to separate this with a little underscore to make it a little bit more obvious. So now we have a parallel plotting script that generates log files based on the date that they started. Now the only downside to this, and I will have to talk about this in a future video, is that the log files that it generates isn't one per plot. It's going to generate one plot file for the total number of plots that you have right here. So in my case, it's 2. Now this makes it difficult to parse the log file versus the one that the GUI makes, where it's one plot log per plot file created. So the last thing I'm going to talk about in this video is making the script file a little bit more versatile so that we can change some of the parameters to change how the script file runs. So we can change the number of parallel plots that we run, and we can change maybe the delay that we do for these parallel plots when we run the script file from PowerShell. So let me go ahead and delete all of this. Now you want to do this by typing out param with some parentheses, and then here you're going to add the variables that you want to be able to change. So in this case we're going to do parallel, and then we can give it a default value. So mine's going to be default 3, and then we're going to create a delay variable so that we can change the delay that we want, and my default is going to be 3600. Now you want to separate these by a comma, and then we're going to change where these are in the script. So in this case it's going to be after the less than or equal. So we're going to change this to parallel, and then we're going to change this value to delay. So now let's go ahead and save the script and then run this in PowerShell. So I'm opening up PowerShell, and then let's run this script. So mine's in the Z, U2, PS scripts, and then Chia. And then now we can run the parameters. So in this case it's parallel, so I only want to do 2 parallel plots instead of 3, and then I want to change the delay to 20 seconds instead of 1 hour, or 3600. So now if I hit enter, we can see that it created one plotting process, and then if we wait 20 seconds instead of the default 1 hour that we have in the script file, it will start another process as well. And then it'll only create 2 of these instead of 3. So here we have the second process starting after only 20 seconds instead of the value 3600. Now if we left these 2 parameters off, it would do the default values. Now if we check the log location, we can see that it did create 2 log files for those parallel plots with the timestamp and the run number attached to them as we wrote in the script. Now I hope this video was helpful in teaching you how to run Chia in PowerShell. We didn't cover everything, but I do plan on making another video to go in a little bit more depth in what we can do. Now you can find all the scripts on my GitHub that I'll post in the description, so you can just run the scripts or modify them however you would like. So I just wanted to give a little sneak peek about what we're going to be getting into in the next video, and that mainly revolves around creating individual log files for each plotting process, because currently the way I showed you, you're going to have one log file for all the plotting processes for each queue. So this is the new script that we're going to be running. It's actually going to be in combination with this one. So this one's going to create the parallel plots, and this one's going to be creating the queue. And we're also going to be going into, cleaning up the progress part of it. So this is the progress that we're going to be seeing. So notice that we kind of took away the stream of it, and we're just kind of condensed it down to, what queue is this? How far in the queue are we in? Right now it's just 1 out of 1 for demonstration purposes. And then what phase is this plot in? And then the percentage. Now I'm going to probably clean this up a little bit, put a percent sign here. And this is going to be the progress bar right here. And this is the time remaining. Now this is approximate, but it does a pretty good job because my plots take about 6 hours. So this looks about right. And then we can see that right now it is generating a log file right here. So this is actually how it's getting the progress. So, be sure to check out that video when it comes out. All right, bye.